Okay, 27.3, least common denominator, finding it. And I want you to go first to what we know about regular numbers and trying to find the common denominator of, let's say, 15 and 21. What you would want to do is think about the ingredients of 15 and 21. So you could say, well, 15 is made up of 3 times 5. That's factoring 15, 3 times 5. And 21 is made up of 3 times 7. So we can see the internal ingredients of these two. That's 3 and 5, 3 and 7. So then what we want to do is we want them to have the same ingredients. Like we would say, well, 3 and 5, what do they not have that this side has? And I'd say, oh, that needs a 7 for that to be the same. And then what does this side have that this doesn't? Oh, this one doesn't have a 5. So you want to give it more than what it has. You have to kind of say, okay, if I made a collection of everything, what would it be? Now, I wouldn't collect 2 3s because you don't see 2 of them showing up in one area. But I would say, you know, they have a 3 involved. They have a 5 involved. They don't both have the 5, but there's a 5 involved. And there's a 7 involved. Those are all the individual ingredients that we saw down here. So the least common denominator then would be 3 times 5 times 7. And whatever that answer would be. So over here, we're kind of doing the same thing. We're saying, okay, what's the ingredients of these denominators? And to find that, we have to factor them first. So when I factored 4x minus 8, I got 4 times x minus 2, because each of these had a 4 in them that we could pull out. Then when I did this part, I'm like, oh, they both have a 7 in them. So I divided out the 7, factored it out, and got this. So now we can see, oh, you know what? They both have an x minus 2. That's something they both have. And then I would say, well, what else do they have? They don't have to both have it. Just what else do they have? Well, they have a 4, and they have a 7. Okay, so the least common denominator then is 4 times 7 times x minus 2, or we'd say 28 times x minus 2. That's the common denominator. Now, if they wanted me to change these so that they all had this ingredient, okay, then what this part was missing was the 7. So I would multiply the top by 7 and the bottom by 7. This one was missing a 4, so we'd multiply the top by 4 and the bottom by 4. And that would make them both have 28x minus 2. But it would change the tops to go along with it in the same manner. So for this next one, if we factor the number 20, it's made of 2 times 2 times 5. And if we factor 70, it's 2 times 5 times 7. So if we make a collection of all the numbers involved, they all have a single 2, but we want them to have the same amount. So if this one has 2 2s, then I want this one to have 2 2s. So we'll count 2 2s here. This one has a 5, this one has a 5. That's good. We want them both to have that. This one has a 7, but this one doesn't. We want them to have exactly the same things. So now we've collected everything with the numbers. Now we look at the x's and we go, okay, what would I have to do? How many x's would they have to have for them to have the same amount? You can't take things away. You can only increase them. So if this one right here got 4 more x's, then they would both be having x to the 6th. So x to the 6th is what we could make them have commonly. And then y to the 4th is what we could make these two have in common. So we would say the least common denominator for this one then is 2 times 2 times 5 times 7. So basically it's 4 times 35. So it'd be 140 x to the 6th, y to the 4th. That's the least common denominator. It's a collection of everything that you have and only repeat something if it's repeated within the same set. So you're saying, how can I make them both have the same stuff? Well, this one has 2 2s. I can make this one have 2 2s. This has 1 5. This one already has 1 5. This has 1 7. I could make this one have 1 7. So that's how we can do that. down here, factored each of these. I could have called this 5 times 2 times 2 as well. But I can see that they both already have a 5, so that's definitely going to be part of the common denominator. Then I'll want them both to have a 7, and I'll want them both to have a 4. Then with the r's, there's 5 r's here and there's 3 r's here, so I want them both to have 5 of them. So we have 5 times 7 times 4, that's 140 again. R to the 5th, that's the common denominator. So then we come down to this one, and if we factor this, this is 2 times 5 times x. This one, you pull the 5 out and you get 5 times x plus 2. So then we need to go, okay, I need all of this stuff together to get the least common denominator. Now we already have a 5. We know 5 is going to be involved. They both already have a 5. I want them both to have a 2. And I want them both to have the x plus 2. That's all of the ingredients that we see here. So that's the least common denominator, 10 times x plus 2. Okay, now over here, this one, we can't factor this any further. This, we can factor this. It becomes x plus 2, x plus 2. All right, so we can see that this has one set of x plus 2, and this has two sets of x plus 2. If we wanted them to have the same stuff on the denominators, this one would need another set. So we could say the least common denominator is 2 sets of x plus 2. And then down here, this is factored already, this is factored already. They don't have anything in common. So if I said, what's the least common denominator? If I want them to have exactly the same thing, that means that this needs to have also a set that says x minus 7. And this one needs a set that says x plus 7. So the thing that they're going to have the same is the set of x plus 7, x minus 7. And then on this one, we had to factor both of these. And we go, okay, we can see if we made them say the same thing. This one already has that 4x minus 1, but it doesn't have an x plus 3. And this one doesn't have an 4x minus 1, 2 sets of them. So our least common denominator would be a kind of a combination of everything. 2 sets of 4x minus 1. And 1 set of x plus 3. That's the common denominator.